Ma'am, we are live. Yeah.
Okay.
Yeah, we are on live.
Okay, that's great. I guess good evening, everyone. If you can hear us. All right. So I think I have the YouTube stream in parallel. So I just have to remember to mute it. All right, so, okay. Hi, Sangeeta, thank you for joining. It'll be helpful if those who are watching live can give us a +1 in the chat if the audio video is okay. If you can see us and hear us, could you please confirm that? Hi, Bhupati. Yeah, I'm going to assume that the logistics are okay because I don't see any complaints. So cool. All right. So as usual, we're here. I'm Neil, and we're also joined by Arjun, and we're hoping to use this as a platform to address any questions that come up. So thanks to everyone who filled out the form in advance. I think we have a bunch of general questions, which we will kind of get to in a minute, but I was wondering if in particular, we don't have any questions in the form from the week 1 materials or from the week 0 assignment, but we have had some discussions over at Discord. So I was wondering if we could start off by addressing that. So Arjun, do you have any general comments or tips about tackling the programming assignments, broadly speaking? Because I think that's something that a few people are tripping up over. And I think there's one problem where everyone's convinced that a particular test case is wrong. So if you have any comments about that, or just generally anything at all, I think that would be a good place to start.
I haven't gone through the comments on the general. I think I've gone through most of the other channels. The general, I haven't been able to go through them fully yet. But I think looking at the other things, I think Zeno has done a great job answering most of them already. I think the one question I think some people were asking about was the cats and dogs and the kind of the slightly number theory-ish parts of the week 1 programming assignments. We will definitely, I think one thing we kind of missed in week 1 was not having subtasks. So subtasks are not intrinsically supported, but we'll try to figure out a way past that. That is to give you partial marks, even if you can solve it for, say, n less equal 10 power 6, and give you 100% of the marks if you can solve it for n less equal 10 power 12, which is, I think, the question asked in the current assignment. So maybe I think just keeping that in mind. So the n, I think both those problems, because these are kind of ad hoc problems, were pretty large. So your quote unquote brute force solutions will end up getting a time limit exceeded because for n equal 10 power 12, you can't even run a simple for loop, right? Because it's only up till 10 power 8 operations per second, and the number of seconds is only a couple of seconds given to you, depending on which language you use. So whenever you see something like n is 10 power 10 or even 10 power 9, and in this case 10 power 12, you should definitely start thinking of algorithms whose runtime complexity is less than order n, right? It should be something like order of log n, or order of square root of n, or order log square n, or n by log n also won't work in this case, but this is the kind of complexity you should be looking for. So in particular, I think one of the main problems you're asking is about the prime factorization problem. So it's a slightly mathematical problem. So think of what exactly. So basically, don't try to just code up whatever the problem asks you to do. Right. So the problem asks you to find the number of good integers, the number of good integers or something of that kind. So just trying everything and checking whether it's let me get my terms correct. What is it called? It's a good number. Yeah. So a number is good number if the number of divisors of that number is odd prime, and the problem asks you to find the number of good numbers in the range of 1 to n. Right. So the obvious solution is to go to each integer from 1 to n and check if it's a good integer or not. But this is definitely going to take up a lot of time because n is up till 10 power 12. And even if you can find whether an integer is a good integer in just constant time, it's going to take order n time, which is going to TLE. So they're going to get a time limit exceeded error. So what you should be looking for is some kind of an observation which lets you. So basically, you should try to solve the problem in your head and try to get some. By in your head, I mean not code it directly, but think of the problem. Think of what structures are there in the problem. Try to work out some sample cases by hand. See if you're not able to get a nice observation at the very beginning, try out some sample cases. Try out for n equal to say 1 to 10 and see which of those numbers are odd, which of those numbers are good numbers, right? And then maybe you'll try to find some pattern or a condition which makes a number good without actually going through the exact definition, right? So eventually what you want to do is you want to reduce your search space. Currently the search space is 1 to n. Anything from 1 to n could be a good integer, but then you can't go through each and every one of them and check whether each and every one is a good integer, right? Because 10 power 12 is not something you can afford to do. So the first step in such things is to narrow down your search space. I mean, maybe you can come up with an observation that any number which ends in a 0 can't be a good integer. In that case, in one shot, you've reduced your search space from 10 power 12 to 10 power 11. Okay, maybe you say all numbers should end with a 0, right? So then you reduce it from 10 power 12 to 10 power 11, right? Because n by 10, right? So try out some, obviously what if it is not true, but this is the kind of thinking you should be getting into. Try to reduce your search space, try to work out on paper what observations you can get about these good integers, and then try to code it so that your complexity becomes much lower than order of n. So if you can list out the actual good integers one by one without going through everything from 1 to n, maybe you worked out in your paper itself that these are the good integers somehow, right? And because such a problem is given, it's probably the case the number of good integers is small. I don't want to say more than that, but if you can do that, that's great. But given that the problem actually asks only for the number of good integers, maybe even if the number of good integers is large, maybe finding the number of them might be easier. So first thing that my thought process in such a problem would be, first, try to figure out on paper whether a number is a good integer or not. Whether there's a mathematical formula or a mathematically easy way to find that, right? And try to get some pattern based on it. Even if this doesn't work, then go on for a formula to find the actual answer, which is the number of good integers. Right? So one of these options should work. I don't think there's any other natural method to go solving such a problem. So try out the first method. If that doesn't work, even if that also TLEs, then try out the second approach. And I think they should give a decent idea of how to go about solving this.
Right. So I think there are a few questions that have come up in the chat for the stream. The first one that I can see is about whether the Python C++ distinction is important. So is it possible that we get TLE for Python, but the private test cases will pass if we were to write the same logic in C++? And I think there was also some discussion in this on Discord. So I think, so outside of NPTEL, my guess is that the answer is no, that on most, I think most judges will not reject the same algorithm written in Python most of the time. That's my guess. And on the NPTEL servers, I'm not 100% sure, because I think we've seen some reports on Discord of things not working as advertised. Basically, if you have the same, the exact same logic written in Python, then it should manage, in the worst case with a 3x slowdown, and that's why you have 3x more time to run your code on the servers. But apparently, this is not good enough, is what we've been informed. So we sort of passed this on to the team at NPTEL. But beyond that, I think the general answer is at this point, I think this distinction is not important. But Arjun, do you want to elaborate on that further?
Yeah, so I was looking at the report. I think that was a pretty detailed report sent by one of the users. I haven't gone through it fully and tested out for myself, but my guess is that is not very accurate, because there are, I mean, the factors involved were the time limits involved are very small, like 0.0603 to 1.3. So when the actual numbers are, the absolute value of the numbers are very small, the blow up, the factor is not that particularly important, because it also depends on, so think of it as follows. I mean, a programming language has some setup time and it has a factor beyond it. So if Python takes, say, 1 second to set up things, and then some extra time. So even if you scale up n, the 1 plus n into c is going to always be there. Whereas the 1 for C++ might be 0.1, right? So just because the 0.1 and 1 gives you a pretty large difference in the absolute value, the 67 doesn't. Just taking fraction might not always be a correct indication of the slowness of a language. But I'll look into the report a bit more and I'll get back to you. I'll reply to that comment on the general section. But my guess is it's not actually 67 times. From what I've seen, it's typically around like 5-6 times slower. But on NPTEL, we've tried to give the test cases small enough that this should not matter. We did have I didn't do an extensive testing of the platform. I just did one code and it passed. But I'll look into that in more detail as well. But my guess is 3 should be fine, particularly because the test data we're giving is not super strong in a sense. So we do make sure that Python solutions should pass. But because I'm not looking into it, I don't want to guarantee you that I'll look into it and I'll get back to you.
Yeah, that's perfect. Thanks. But outside of NPTEL, usually this is not a problem, right? Python versus C++.
Yeah, so
if it's same logic.
It's definitely not a problem in beginner problems. Again, particularly because of the fact that the beginner problems typically have constraints pretty small. But when you get onto, even in intermediate, it should usually not be a problem. But when you get onto slightly more advanced topics, sometimes it can happen that one language has a higher blow up than other languages. It's not, you can never have a single constant and say this language is C times slower than the other language. The C varies quite drastically based on what structures you use. I mean, a set is implemented one way in C++, it's completely different in something like Python. So even input output, like depending on sometimes, so there are languages whose main bottleneck is input output. So if you have a problem where the input is small, but the complexity is large, the difference in the time complex in the running times won't be different between C++ and that language. Whereas if input, you have to input say 10 power 6 integers, then because input is slower in the other language, the execution time that becomes the main bottleneck. So there are various such things. So in general, I would say Python, it should not matter for beginner levels. But when you go on to advanced, mainly because it's not tested, because there are only like typically C++, almost every problem is tested using C++. Java, most of them. Python, not so much, because there are not many people using it. So I think that's kind of the main reason why you'll definitely find at least some advanced problems where getting it accepted with Python is going to be hard. So for this reason, even in IOI and ICPC, I think Python is not allowed. And even when for a couple of years when it was allowed, they said that it's not guaranteed that you can AC using Python. So they kind of made it a second tier of language.
Right. So use at your own risk.
Exactly. Yeah.
Right. Makes sense.
But I think for this level, it should not matter. You can go ahead with.
Correct. Yeah, that I think that makes sense. I mean, whatever little experience I've had, I've noticed that like a good algorithm with something like PyPy being chosen as the compiler, typically is no trouble on platforms like say Codeforces or let's say even at Coder. But again, generally speaking, more of the beginner contests or the education contests, I think that's been more of the ones that I've dabbled in. So I think it should be a pretty safe bet for the scope of this course for sure, and we'll try to make sure that you don't have too much trouble on the NPTEL servers either. So, but yeah, I mean, once you get past this, I think you are probably automatically at a point where you have picked up some C++ on the way or whatever. So it should hopefully not be a issue going forward. But as I said, I mean, I think on CodeJam, for instance, I think I have seen like a website that compiles CodeJam stats, which does show a lot of variety, especially from the older days of CodeJam. I think when the compilation didn't happen server side, right? I think you just had to upload, the output file. So I think back then, I think there was a lot of variety, and I mean, I think people use much worse than Python. Like I should use guarded adjectives, but I think there are contexts in which the language doesn't matter so much. But yeah, I mean, I think at some stage the differences do start showing up, but they shouldn't be showing up right now. Certainly not for the week one problems. So if you're facing issues specifically on NPTEL, I think you've already had one sort of a bug report in some sense. So we'll be taking a closer look, like Arjun just said. But by and large, so that I think answers the first question here about TLE in Python versus C++. So I think we can probably move on. I think there's been some discussion about, some of you being fairly convinced that the test cases are incorrect. And I think I can say with some confidence that again, for the official assignments, typically the test cases are not going to be incorrect. And in fact, for the most part, I think we've even had other people who are taking this course who have really chipped in to help clarify why the test cases make sense. So definitely a shout out to all of you who have been pitching in. But once again, so I think there was the problem about the cake, Swayam and the cake. So I think one of the test cases there threw a few people off, I guess. And I think there were like maybe a couple of other edge cases. So without getting into specifics necessarily, Arjun, do you want to reassure everyone that the test cases are fine?
Yeah, I'm fairly certain they're fine. But I can even go through the particular instance that the current question is about. So week one programming question 1, by test cases, I'm guessing you mean public test cases, or are you talking about the private test cases, Abhinandan? If it's a public test case, I can go over it and actually tell you why we think it's correct. Private test case also, I'm like, I would put it at like a 99% certainty that they are correct. We've tested it using probably like 5-6 different solutions, so there should not be any issue.
Also, Nikhil has a similar question. Programming assignment 2 private test cases are not right. The algorithm is looking perfect. So what do we do now? And as I said, I think when you are in that zone where you are completely convinced that your algorithm cannot have a mistake, I think it's disappointing to hear the problem setter telling you that, we are not wrong, but you are. But I mean, so that's not really what this is about. As Arjun was just saying, these have been stress tested quite a bit. So the chances that, I mean, further, I think, a lot of your peers have been also experiencing that the answers are getting accepted and so forth. So I think there is a reasonable amount of evidence that there isn't an issue with the test cases. So as Sherlock Holmes would say, that leaves us with the only possibility that probably there is something wrong with your approach. It may be like a really minor thing. I mean, sometimes, yeah, like the kind of things that have gone wrong and things that I've submitted are like just so silly in retrospect. So, I mean, I wouldn't like worry about it too much, but I think it's a good idea to just carefully go over whatever you're trying again. So I guess, yeah, so I'm not sure if Abhinandan wants to be more specific about the test case, that he's talking about. I don't know if you have a chance, Arjun, to look at test case 4 of programming assignment problem 2 in week 0. I think that was the one about the cake. And there was a mail in the mailing list saying it was given 5-5, and the explanation it's 5-3. So I don't know if that's something that you want to. I think this has been explained. Yeah, I think it has been explained a couple of times, both at Discord and as well as on the mailing list. I think there's been some discussion, but I don't know. Sure. Right.
Okay, I know this problem. Which test case? Fourth input is wrong. Fourth input is 5-5. So maybe I'll do a short recap of the problem. The problem is you're given n and k and n and x, and you're allowed to cut any number of integers from 1 to x, and whatever is remaining, that is the cake, that is the amount of cake you get. So when it is 5 and 5, you're allowed to cut 1 slice, 2 slices, 3 slices, 4 slices, or 5 slices. When you make one slice, when you call one friend and you have just 1 slice, you give the entire 5, the entire cake to them, because 5 by 1 is 5 and 5 mod 1 is 0. So you don't get anything. When you call 2 friends, you're going to give 2 slices to each of them, and the remaining 1 slice comes to you. So when you call 2 friends, you get 1 slice of cake. When you call 3 friends, 5 by 3 is 1. So you give 1 slice to each one of them, and the remaining 2 slices come to you. When you call 4 friends, you give 1 to each, and the remaining 1 comes to you. And when you call 5 friends, each friend gets 1 slice and you get 0 slices. So the best scenario in all of this for you is to call 3 friends. So they'll get 1 each and you get 2 remaining, right? So the answer in this should be 2, which is the answer given. So I do not see any issue with this. So I hope this makes it clear. If the person who had the question is in the chat, please let me know if something is still not clear. Maybe the misunderstanding which some of them might have had was assuming that you're only allowed to call X friends, but you're allowed to call anything between 1 to X friends, right? So that usually is one misunderstanding in this problem. So I'm not sure if that was the exact.
Yeah, I think
that was the exact. Yeah. Okay.
Yeah, that I believe you're right about that. I think it says it is given 5-5, but in the explanation it's taken as 5-3. That was the way the doubt was phrased. So I think the implicit assumption was that because it was 5-5, you are constrained to only have 5 people over, or something like this.
Correct. So I think it's at most 5 and not exactly 5. So I think that's the main.
Right. Absolutely. So I think, yeah, that's very useful. So right, so that is one that I can remember where a clarification was requested. And I think the other one, as I said, I think I'm not sure if Abhinandan is still around. He had mentioned something about week 1, question 1. So we can come back to it if there's something more specific there. I think Ryan had a question. Sorry, yeah, go for it.
Okay. So Nikhil and I think someone on Discord also had asked this. They were asking for a public test case, which is a large test case. I think I mean, you would not get this typically in a contest, but I think it's totally fine to ask it here. So we will add something. That's a fair point. I'll make sure to add some slightly larger test case as a public test case as well. Point taken. I think Zeno had replied to this as well with some test data. I'll add it to the actual problem as well.
Right. Yeah, I think, yeah, I did notice that there were some test cases that were shared at Discord by Zeno. That's right. And I think Ryan had a question earlier about a time complexity that has already been achieved, and should it be reduced further, or can it be? So I think this was root and log n.
Yeah,
I'm not sure
that
for
sounds
which
about
problem.
right. I think he's talking about. I don't want to get into detail about it, but it looks about right. I think for n equal to 10 power 12, that should definitely fit within the time limit. So I think you're good to go.
Okay, that's perfect. Yeah, how to deal with those cases where public cases are less? I think we are going to fix that as we just discussed.
Maybe
And
I'll also give a
yeah,
bit more context. So
sure.
in general, in most platforms, you will not get kind of like large data as public input. One, simply because it's just not feasible to put it in your test data. So this happens to be a problem where the input is small, even though the value is what is large. But that is, as I'm sure Neeldhara knows, it's very rare in most problems where the input size is smaller than the input used in time complexity. In general, for such problems which don't have it, you just can't get large input as a sample input. In such cases, if you're like totally frustrated, you've tried for like say 1 hour to debug your code, you're like absolutely sure of your time complexity, it should pass, and you're still not sure what's happening. I think the only other way, I would still suggest just read your code, dry run it, and see what's happening, and trying to find out what the issue is. Do some debugging things. But if you're like really frustrated, one thing you can do is generate your own input. The platform can't give you large input because it's just infeasible. But locally, if you have an IDE and you're working on a local system, and you're somewhat familiar with the terminal and generating things, you can generate your own test data and run it a slightly large test data. You could write a brute force solution which passes for that thing, and then run your code on the slightly larger test data and run the brute force as well, and check whether these these outputs match with each other. So I have a small doc written on this long time back. I'll try to share just like a basics of terminals, and what kind of like any Unix based OS, you should be able to figure out how these things work, like basically piping of files and diff and so on and so forth. So that kind of brings me to another point which is that for most computer programming, Unix-based OS is, I think, significantly better when you get to a slightly advanced level, as opposed to say Windows. One of the main reasons being like on the terminal you get a decent amount of freedom and power to do things. With Windows, of course, now you have the I forget what it's called, some inbuilt terminal, like some Ubuntu, like Linux emulator kind of thing.
Is it a PowerShell or something? I don't know if that's the Windows.
No, PowerShell is Windows based. No, but now they also have this like Linux emulator inside Windows for Windows.
Yeah.
I forget. That doesn't. I forget the name. Yeah, I mean you could use something like that as well. But in general, I think it is preferable to have a Unix-based OS. One, because there's just a lot more documentation on that for CP-related tasks, and I think in general it definitely helps. So I'll try to send that. I'll maybe spruce that up a bit, and I'll try to send it for someone who wants to start using terminal for these things. But again, for beginner level problems, I don't think it's vital. It's probably a lot more efficient for you to just read the code, but it's definitely good practice to learn how to debug codes using test data that you generate. So yeah.
Right. I think I also just added a small pointer to a website called UDebug, which has like a repository of, I think, community contributed test cases for very many problems.
Correct.
And many of them are, I think, early stage problems as well. So chances are that for a problem that you're practicing, you might find something useful on UDebug. Because even on code forces, I mean, sometimes when your program fails, the interface will reveal a few more test cases, but the truly large ones are literally truncated in the browser. So, it's just like a weird limitation, I think, of how things are set up, that the larger test cases will not be exposed to you. But on UDebug, I think you can actually download these files and play around with them. The only other platform I know of that does this, I think, is Hacker Earth. I think they allow you to actually download test files.
Even
which,
AdCoder doesn't.
yeah,
AdCoder has
I think they
it's
have a
valid.
link. Yeah, they have a
Yeah,
link
there's
to a
a repository
Dropbox
of all
page.
the Dropbox. Correct, yeah.
Yeah, exactly. So yeah, they do have, I think, random test cases and I think handcrafted test cases, both ways. That's true. I think one thing that does take some practice is like, so you probably, yeah, I mean, sometimes you'll have a brute force solution that will, run on your computer, but it'll not be valid for the judge. So then you can try your brute force solution on a test case that you have generated yourself randomly. But let's say the brute force solution is some n factorial or 2 to the n, then it will probably not run on your computer also. So I think it's a little bit of an art to come up with a large test case, which will still stress out your program, but for which you somehow, by some other method, the correct answer, like because of a pattern that is there, some structure that is there. So that is something, again, yeah, I'm sure Arjun's document will also help you like get started on that path. But yeah, in general, I think just being able to act adversarially for your own code, and on some platforms even just being able to attack other people's codes, I think you get points for that. So this is a skill that definitely doesn't, I mean, it's a good skill to develop for sure. The only thing is, yeah, I mean, how much do you want to focus on it? I think the beginner stages, I mean, unless it's a situation that you're actually stuck in, I think the focus is probably a little more on actually learning techniques and just being careful about your implementation straight out. But I think this is a great complementary skill to develop, while you're at it. So yeah, I think between the resources that Arjun will be sharing with us and UDebug and a little bit of trial and error, I think hopefully things will only get better. And I think we will also try to share larger test cases for these problems going forward as well. So I think for future programming assignments, subtasks and larger test cases as something that we will try to account for as much as possible, or whenever it makes sense in the context of the problem. So, all right, cool. So I think Anjali has a question, which Arjun, if you can see it, do you want to take it on?
Yeah, so Anjali, again, because it's a assignment which the deadline is still not over yet, I would not want to get into a lot of detail. But I mean, it basically boils down to a small mathematical observation. I mean, similar to kind of what I was saying earlier. You need to kind of figure out on paper what the range could be. So it's exact. I mean, I think you're pretty much on the correct track. You want the perfect range, right? So try to maybe find the range. Try to find the constraints from each integer of the input, and then see how those ranges across all the integers interact with each other. I think this is how much the hint I can give to be. I mean, like, I should be fair to people who are not in this call as well. So I'd rather not get into a lot more detail. So I've written a small reply to this, something along these lines on, I think, the week 1 Discord chat as well. So you could have a look at it as well. But we'll definitely discuss this in detail once the deadline is over.
Yeah. I think that's a good point in general. I think going forward, once the deadlines start sort of finishing, then I think in the following live sessions, we can discuss the materials that are safe to discuss, essentially. I think we could use these sessions for that. Yeah, I think, so do you just want to continue going through the chat?
Yeah. So Gandhar, will VS Code run fast in Linux machine? So it's not the fact that Linux machine or Mac OS is faster than than Windows. There is, if at all there's a difference, a very minuscule difference. It does not make any difference. So speed is not something you need to worry about. And whatever the case, when you submit it, it's going to run in NPTEL's server. Which I'm guessing is Ubuntu. I'm not sure. It's some Linux-based thing. But it does not matter at all if you're using Windows. That is not the question here. The point I was trying to make was rather the tools that you have to work locally are somewhat better in a Linux-based environment than in a Windows-based environment. But don't let that stop you from using Windows if that is what you're comfortable with. There is no issue at all. But if you're starting out and you're not sure which OS to go for, then I would definitely recommend using a Unix-based OS. Okay, so you have an Ubuntu machine, then great, just go ahead with it, I would say. But it's not for the fact that it's faster. It's only for ease of use in some sense. Windows subsystem for Linux are super slow. Oh, wait, are super, okay. Windows, that's called subsystem for Linux. Okay, great. If you figured out how to use that, amazing. I think that's very good. Elaborate. So I think what Shivam is talking about is the Linux kind of like virtual machine, which is available on Windows now. I can look it up and let you know what exactly it's called. I've frankly not used it. So basically, you can open an instance of. I'm not sure what exactly this is, but some instance of Linux you can work with. The Linux terminal you can work with inside Windows. So I think that is what Shivam is talking about, and that is what I was alluding to earlier. But I really have no idea if it's fast enough for competitive programming, like fast enough as in whether it has enough memory allocated to it. I don't know the nitty-gritty details, so maybe I'll ask someone who is familiar with it and I'll get back to you. But that is definitely something you can explore if you are a Windows user and you want to get into some Unix-based tools as well. CSCS problem set allows. CSCS problems have. Oh yes, CSCS problems do have open test data. Correct. Wait, really? Yes. Yeah, that is a separate. Is it good or bad to see solutions? Neeldhara, do you maybe want to take this?
Okay, I don't know if I'll give the right answer. Actually, I'm not sure. It depends, and it depends on, I think, the context of where you are and what kind of practice you want to do. I think Arjun had actually talked about this in the last stream, if I remember correctly. I mean, I think the formula was to generally give it a decent shot yourself. Like, I think spoiling the solution immediately, I mean, apart from the fact that it just really does take away the fun of it, it's not clear that that's going to make for effective practice. So I think, and also I think the effectiveness with which you appreciate the solution will increase way more if you spend even a little bit of time upfront thinking about the problem yourself, because then you'll be able to quickly relate to a lot of things, and at some point you'll identify, this was the the moment of truth. This was the point where let's say the editorial bifurcates from wherever you were stuck, and so on. So usually, like, at least the first few steps will be fairly consistent with whatever the editorial says, and that's always a good feeling to know that at least you were on the right track for some time. So I would say I cannot imagine too many situations where immediately looking up the solutions is a good idea. especially if your goal is to learn and especially if you are starting out. On the other hand, you have to strike a balance. I mean, you could probably be stuck on something for ages, and that's not at some point that can also get frustrating, and the situation kind of flips. So you want to make sure that you get out of your funk just in time. And I think the suggestion last time was that maybe instead of looking at the solution in its entirety, just try and look at the tags. For example, I think the CodeChef interface now like hides the tags by default, and you can you can click on a link which says show tags or something like that, because the tags already give away quite a bit about the problem. I mean, in this, it's like telling you that in an exam this question is from that chapter. It's going to ring off some bells, and it'll maybe set you off on the right path, and maybe that's all that you need. So that'll that'll be very good and confidence boosting if you can get it done with just that much of hand holding. After that, I think I mean, if it's especially a challenging problem, you may want to consider consulting the editorial in more detail. I think these days there's also a lot of video materials, so you're really spoiled for choice. You can either read an editorial or watch one, or you can watch a stream or whatever. So eventually, I think it's probably better to look up a solution than to be endlessly stuck and frustrated, for sure. But I think an intermediate strategy, which is even better, is to discuss with somebody. And I think this is also what Arjun was saying last time. Find somebody who has solved the problem, and ideally somebody who is like an accountability partner or somebody you have a study group with, so they also know where you are in your journey, and they'll be able to quickly tell you if this is the sort of thing that you can already do with your current knowledge base or not. And that again is like a very useful sort of a hint, because for some problems you just need to know a certain technique before you can solve it. So definitely it's not very efficient to just keep being stuck on something that really is a little bit out of bounds. So having access to that kind of information is definitely helpful. So I would say it's I mean, it's a long-winded answer, but really, I mean, a short summary would be, do try it yourself a little bit, and then just keep taking a peek, and don't spoil it completely for yourself immediately. Usually, that's not helpful. Discuss with somebody. I think that's probably more constructive than looking up the solution immediately. But as a last resort, I think looking up the solution is a better option than giving up altogether. Yeah. So.
And,
Cool. So I think I just plagiarized much of what you said, Arjun. So yeah, if you
I
want to
think you
add
put
something,
it much better. I would just say, even if you're looking at the editorial, you can try to look at it section by section, if that is a section-wise thing. And yeah, I mean, ideally, at least my ideal version of an editorial should be just hints, and just take you through the thought process hint by hint, and get you and make you arrive at a thing. But not all editorials are. I mean, of course, different people have different tastes. This is just my personal taste. So if you find an editorial like that, then it's perfect. Just look at the first hint, understand that, and try to solve the rest of the problem on your own. If you're still stuck, look at the second hint, and so on and so forth. But even otherwise, I think in general editorial thing also, you can just look at the first 2 lines. Okay, so this seems like they're building a graph, and then go back and try to do something. Then maybe go and look at what exactly the graph they're building is, and then do something else, and so on.
Yep, exactly. Yeah, I think that makes a lot of sense. Absolutely. So yeah, I think it looks like we've addressed that. I guess. Okay, so Nikhil, for learning graphs, please recommend a YouTube channel. Actually, as a matter of fact, I do know a couple of YouTube channels offhand that I like, so I can just try to drop a couple of links. But Arjun, do you have any favorite resources?
Not really. I'm not well versed in the YouTube verse.
Right. Actually, I don't remember. Did IPC have like a separate playlist for graph problems, or was there a day that was focused on it?
I have to look at it. I don't.
I also can't remember, but I mean, I do remember that there was a lot of graph content, but I don't know if it's curated separately or not.
Yeah,
but
I think it was mostly on a day-wise thing rather than a
correct.
That's actually a good
yeah.
We should look into it and make it as a topic-based playlist as well. Yeah.
Right. So yeah, so definitely I think the CodeChef YouTube channel, Nikhil, is a good place to start for this kind of material in the context of contest programming. So I think a lot of the material there is through examples of problems on CodeChef and other platforms. So I think that's a great place to start. But I think if you're looking for general graph theory material divorced from competitive programming, I think there is a channel by William.
William?
Yeah, I could be completely botching the name. Let me just check. So William Fest, yeah, William Fiest, I think. So yeah, he has a bunch of examples of graph algorithms and so on. I hope I got that URL right, because the username looks quite different from the readable name. But anyway, so that's probably one place. Arjun, was there something else that you wanted to recommend? Or yeah, I think this has a fair amount of material. It should definitely keep you busy for a while, and I think it's pretty good. Of course, the usual suspects are like you could also do the regular algorithms courses on NPTEL or MIT OpenCourseWare or Coursera or these other platforms. Most algorithms courses will have like a good chunk of like their time dedicated to graph algorithms, at least the standard ones. So there are some absolutely amazing instructors out there. So if that's the kind of material you're looking for, yeah, I mean, I think you can find a lot of that just by browsing through. So NPTEL has 2 or 3 algorithms courses at least, which are even quite recent. And Coursera and MIT OpenCourseWare also have some great courses. So we can add links to all of these in the course website in due course, so you can look them up from there. But if you want something that's just completely focused just on graph algorithms and is very visual in its approach, I think you can look up the channel that I just linked to here. Yeah, that's correct. Yes, thanks, Kranti. William Fiest is right.
Sorry, once it's a validity, give us the link.
Oh, I think just after Mike's suggestion for Paul Marvin, I think. Let's see. Hopefully it went through. Like I know sometimes YouTube blocks links.
Yeah, because I don't see it. I mean, wait, are you Mike? You're not Mike, right?
No, so,
okay.
So Mike has said William Lin, and I thought I posted the link just above that, but I'm not sure if
I don't see it weirdly.
Okay, all right, okay. So I think it's possible that oh, sorry, I think I've also, as I said, I'm probably botching the name, which I think I am. William. Okay, so
yeah, do you see the link I gave? I've posted, or is mine also blocked?
No, also I don't see yours either. So I think we may have to request, our colleagues from NPTEL to post it at some point, or we can do it later, I think, after this session. But yeah, I think everybody has shared the name that you need to look for. Like, so if you basically Google, if you do a YouTube search for this, you'll find the channel. So that's fine. Yeah, thanks. Cool. Yeah, it's just weird that links don't show up. I think I've been confidently sharing links.
And particularly YouTube videos. I can imagine if, I don't know why.
At least if it was a Vimeo video or something, okay, YouTube wants to block it. But yeah, I think they're shooting themselves in the foot a little bit here. But okay. Yeah, so I think that was the question about graph. For learning graphs. What's the best way of approaching a problem? Again, I think we discussed this to some extent last time. But yeah, I mean, Arjun, do you want to take this? Okay, I mean, sorry, just before that, I think the others are slightly easier in scope to address. So maybe I'll just quickly go over for the next week prerequisites. Next week is searching and sorting, and you can find the prerequisites on the course website. I'm not posting a link here because I don't think it'll work, but you can find it from the announcements channel on Discord. And so the course website is divided into weekly sections. So if you go to week 2, you will find links to specific prerequisites for next week.
So maybe I'll take Aryan's and
yes,
yeah.
please.
So the question is, in contests, there are some situations in which I'm confused whether my approach to the problem is completely wrong or whether I'm on the right track and I need to build more upon it. This is a very, very, very fair question to ask, and I don't think there's a clean answer to this. So I can just tell you what I try to do, at least idealistically. is kind of a BFS approach rather than a DFS approach. That is, you see a problem immediately, probably like one or two approaches strike you that it might go along this way. Spend some time on it, see if it is promising. But I would definitely recommend not spending a whole lot of time on just one approach. Maybe you see a problem. The first instinct is for you to think that it's maybe a DP problem, and you get into that rabbit hole. But things don't. You keep ending up with some bottle, but that's some hurdle. Then you should definitely kind of cleanse your palate and come back to the top again and give a rethink about it. So one thing is, whichever approach you're thinking about, the more you think about a problem, even if it's in one particular approach, you will definitely gain some intuition about the problem. You'll get some knowledge about the structure of the problem, like an internal structure of the problem is something you should get a better idea of rather than when you first started out. In other words, when you started out, you saw the problem, you got an approach, maybe that approach was wrong. But the more you think about that approach, one, you'll get to understand why you think that approach will not work, right? So that itself should point to what other approach could work. That is, say when you're doing a DP, so maybe the first thing you realize is, okay, so this DP requires like an n cube, n cube states, but my n is say some 5,000, so I can't have n cube states. So then, okay, so I should reduce the number of states for which either there is some observation which lets me reduce it, or there is some greedy algo which kind of breezes through all this and just reduces my search space much better, right? So you can think in terms of like kind of like search space again, which I keep coming to quite often. It's a slightly hard concept to get used to, I think, thinking kind of abstractly in terms of search space. But I think once you get used to it, I think it helps a lot. Not going too much into the rabbit hole of one particular approach, but thinking slightly from more abstract overview and say, okay, I'm working with this large search space. No matter how efficient my algo is, if my search space is so huge, I can't expect to do much better, right? So then the second step should be to prune the search space as fast as possible. So either you do it on paper and say, okay, my search space, I can actually, before even writing a single piece of code, I know that my search space can be reduced to a small fraction. Or, okay, there is this approach which greatly, in a few steps, maybe it's a binary search, right? So in a few steps, you reduce your search space very quickly, right? And then maybe inside that you can take some different algo. Okay, I was just giving a very random example. My larger point was basically, even when you're looking at an approach which turns out to be wrong, you should get some takeaway from it, and that should help you in the next approach, right? And you should be quick to kind of switch between approaches. Don't spend way too much time on one particular approach itself. If the DP doesn't work out for say some 10-15 minutes after thinking, you don't need to totally ditch it, but give a pause, try some other approach. That will give you some insight which might help you to go back to the DP problem and help you cross that hurdle. Think of a totally different model. Maybe there's some graph modeling which makes my life easier. Yeah. So basically, I would definitely say you should not spend too much time on one single approach. So even if you're not sure that it is completely wrong, even if you're not sure if it's correct, do take a break and see if there is some other approach which works. Spend some time on it. If that doesn't look promising, look for a third approach or come back to the first approach and try it. So that is what I meant by a BFS approach rather than a DFS approach. Don't just go down one rabbit hole totally. Try this for some time, then get back to some other approach, maybe some other approach, and maybe eventually some amalgamation of all these approaches gets you to the correct answer. Yeah, so I know this is not a very neat answer, and there is no correct answer for this, but at least this is a this is at least what I think would be kind of like a nice way to go about things. Again, this is only from the context of competitive programming, right? This is not definitely a good advice for, say, a research problem or problem where you have a lot of time to work on. Just from a short contest perspective, I think this is something which would help.
Yeah, thanks. Actually, I'm not sure. I think it's useful probably beyond short contest situations as well. You never know. Yeah, no, I think, yeah, it's like, I guess, putting all your eggs in one basket. I think fine tuning that the degree to which you do the back and forth is a big part of like the practice. I think helps you develop that instinct for the trade-offs. I mean, of course, at some point you need to just roll up your sleeves and code a solution. At some point you need to commit enough to be able to get to that point. But until things are looking uncertain, I think doing the back and forth a little bit definitely makes a lot of sense.
What's your perspective on this from a research point of view? Like when you're working on a problem?
Yeah, I mean, yeah, this is yeah, I'm not sure. I mean, it's exactly the same thing. I mean, you certainly have more than 2.5 hours to figure out a research problem for sure, but it's still usually you would want it to be a finite process. So at some point, I think figuring out these trade-offs is probably a big part of an individual researcher's style. I think styles vary a lot, as I think you've also said. So, but I think the one extreme would be overcommitment to one approach, I guess, and being really stubborn about hoping that it pans out, versus the other would be not spending long enough and getting impatient too quickly, and saying that this already is something that you've decided to ditch after spending too little time on it. So you probably want to take on some sort of a reasonable middle path to be able to actually get somewhere. So in that sense, it feels very similar. I think it's just scaled up a bit. So I guess, what is the time to move on in the context of a live contest is probably like a few minutes, and for a research problem, maybe like a few weeks. So the scales are different, but I think the high level approach is probably not all that different. So yeah, I think the advice does apply a little more broadly for sure, with appropriate scaling. So, okay. And I think that to some extent also addresses the earlier question about how do you start approaching a problem. Of course, I would just say that the additional thing is that all of this will be I think projected on your current toolkit. So, so in terms of your learning strategy, you want to divide your time between strengthening the things you already know by practicing more and more, and also learning new things so that it enables you to practice more and more different things as well. So you want to learn new things, but at the same time, you want to make sure that whatever you think you've already learned, you've actually learned it properly. So again, a quality quantity kind of trade-off, and hopefully you'll get the hang of it as you go along. And yeah, I think another tangentially related issue is like proofs of correctness. I think if you're doing an algorithms course, it's absolutely key that you are somewhat particular about having understood why something works really well. So even if it's not absolutely formal, rigorous language, I think being able to come up with a decent rationale for why things work out is a big part of the learning objective in an algorithms course. Whereas here, I think it's going to be our best effort to make sure that we maintain that level of rigor in our lectures. But when you're like in the heat of the moment in an actual contest, you're probably not expected to exercise that level of rigor in terms of your surety. Of course, you want to be sure enough to the point where, like Arjun was just saying, I mean, I think, up to a point, you should also know when you cannot be confident about something that you have just come up with. So, you probably have an approach, but being able to quickly debug it in your head or on a piece of paper, even before you spend time coding it up, I think is a useful thing to be able to do. But at some point when you feel that things are okay, I think it's probably all right to go with your instinct if you're feeling reasonably confident, and you probably don't want to. So especially so for instance, for numbers game that happened in week 1, we did work out a proof for why everything converged to the golden ratio. And this will make sense only if you've seen the lecture, so ignore this comment otherwise. But that's a proof that you probably don't want to worry too much about during the contest. I think if you see the pattern in the numbers, you see things converging, it's probably a good enough point to, just say that, okay, let's try to code this up. And which is why it also makes sense to generally develop your coding speed and, get to the point where you can code things quickly, so that just in case this was a shot in the dark, it didn't work out, you have enough time to back up and, come up with an alternative or whatever. But yeah, I mean, even in the upcoming lectures, you'll often see that we get into justifications quite a bit in the lectures, but that level of rigor is not expected probably within the duration of a contest. But I think for me, a big part of upsolving is also coming back and not only doing the things that you haven't solved, but also the things that you did solve, just actually convincing yourself that you know why they worked out, I think is, it's useful trivia, and it's good to it's good to go back and fill in the gaps in the logical reasoning if there were any gaps when you came up with your ideas in the first place. So yeah, I was a bit of a tangent, but I kind of wanted to get that off my chest because yeah, so
This is
cool.
also something I always rant about to people with proofs. It's a
Right.
pet peeve of sorts.
Right, yeah, I mean, it's always amusing when, like, you have an accepted answer but you don't know why. It's kind of how, if you can't explain it to your friend as to, so then it just feels a little bit like the end-to-end journey feels a bit incomplete.
Exactly. Proof by AC is not an accepted proof.
Yeah, exactly. All right, okay, awesome. So yeah, I think we're just about on the hour, and by coincidence I don't really see any new
There's one
questions in the chat.
question by Kalyan.
Oh, right. Yeah.
We need to have an intermediate level knowledge to start CP, or can I start without a very good knowledge? You can definitely start without a good knowledge of DSA. I mean, even if you're starting out learning DSA, I would still recommend starting out with some Div 3 contests, educational rounds. There are definitely the first couple of problems, at least in a Div 3 contest, do not require you to know any data structure or algorithms. You only need the main prerequisites are just that you are decently comfortable with a programming language, and you have enough time to comprehend what the problem statement says. And using just some common sense, you should be able to come up with a solution for these things and convert it into code. So the answer is definitely you don't even need intermediate knowledge. Just with a beginner level knowledge, definitely you can get into the world of CP.
Yeah, I think that also addresses some of the questions that had come in from the forum. I think a lot of people were saying that they were just starting out. And I think just in case, I think one question specifically said that they were not able to follow the week 1 material, and it was challenging. So I think that should definitely not discourage you from getting started. I wouldn't say that the week 1 materials were at the place where were not the absolute beginning of, so I think they were probably a little more challenging than, let's say, the first problem in any contest. So so I think those are just great places to warm up, and you're going to evolve as you go along. But yeah, I mean, if you're finding the material to be a total disconnect, chances are that it's because you've probably not had exposure to algorithms before, and maybe that's why it feels a bit alien. And I'm certainly optimistic that this will not be the last time that we're offering this course. So you're very welcome to pick this up in the next run. And you can always come back to the materials on YouTube, whether or not it's an official NPTEL offering. So feel free to just come back to it when you feel a little more ready, if this is your situation. But at the same time, if you are kind of if it's just that it's taking you a little bit of time, then I would encourage you to be patient. But in case it's that it's not making any sense at all, then please don't be discouraged. I think it's just a matter of timing. Perhaps just come back to it after a little more background, maybe a little more practice with the warm up kind of problems. So yeah, I think now we probably have covered everything. I don't see.
Yeah.
I think that there was a suggestion to take questions from Discord in the live sessions as well. So since I didn't make an explicit thread calling for questions, and I think most questions that have been posed on Discord have been answered, I think it's probably not very relevant for this session, but maybe for upcoming sessions, we could also solicit questions directly from Discord. Cool. All right. So I think we can call it a day here. To everyone who is still listening, thank you so much for joining. And we'll hopefully see you back next week, approximately at least. Yeah. So we are tentatively planning to have these live sessions regularly around this time every week. So we hope that, at least by default, that's when we will meet next. So thanks once again for joining, and, have fun. The week 2 videos should be up in the next 24 hours, hopefully. So I hope you have a good time on them, and I will see you in Discord and later next week. Bye for now.
See you. Bye. Thank you.